Okay, step 3, you determine the critical rejection region. So this one here, when they say you determine the critical, they are talking about critical value of x squared. Whenever you're given a question, they will give you a table, then they will say, maybe calculate the critical value of the test statistic. The word critical value means that you're going to use table 4, show you. So before you calculate the critical value, you must make sure that you calculate degrees of freedom by using this formula here. Using this formula. R is equal to number of rows. C is equal to number of columns. I'll explain this one. Let's look at one question where we are required to calculate the degrees of freedom. After degrees of freedom, I will show you how to calculate this one here, the critical value. The critical value. Let's look at one question. Chapter 9 and then chapter 10. Chapter 9, chapter 10. Oh, yeah. When we are done, then we'll discuss this one because it's based on chapter step 2. Okay. Yeah, let us look at this. Well, let us look at option 4. Option 4, they say the degrees of freedom is equal to 3. So we must prove by using which formula? This formula here. This formula here is equal to r minus 1. Now here, what's our r? R, they're talking about the number of rows. We have row number 1, we have row number 2. So r is equal to 2. Then the columns, the number of columns, we have what? The number of columns here, we have column 1, column 2, column 3, column 4. So C is equal to 4 here. Is equal to 4. Column 1, 2, 3, 4. Then rows 1, 2. Then we substitute. It's r minus 1 and it's 2 minus 1. Close bracket, then here, then open bracket, then the column total, remember formula, it's 4. So 4 minus 1 here. Okay, 4 minus 1. Okay, 4 minus 1. Then we say 4 minus 1 here. Okay, then which will give us, here, which will give us 2 minus 1 is 1. Then open bracket, 4 minus 1 is 3. 3. So here, 1 multiplied by 3 is equal to 3. 1 multiplied by 3. So option 4 is correct. Option 4 correct. Option 3 correct. Option 2 correct. That's how you calculate that's how you calculate degrees of freedom when you are dealing with the chi-square test independence. Any question? Okay, do you all understand?
Yes.
Okay, let's calculate degrees of freedom for this one here. Okay, here we say what? Remember it's R. R is row, number of rows, then C is number of columns here. Okay, then here, number of rows, we have what? 1, 2. We have the row for 0 kilometer less than 10 kilometer. Then we have row for 10 kilometer less than 50 kilometer. So row is equal to, the number of rows is equal to 2. Then for the column totals, we have column for bus, column for car, column for train. We don't count the totals. Remember, we don't count the totals. When you count the number of rows, don't count the totals. When you count the number of columns, don't count the totals here. Please don't count the totals. So here we have number of column 1, 2, 3. So column is equal to 3. Then we substitute. We say 2 minus 1, then close bracket, then open bracket, we say 3 minus 1. 3 minus 1, then close bracket. This one is 2 minus 1, 1. 2 minus 1, then 1. Then 3 minus 1, 2. Therefore, 2 multiplied by 1, it's 2. That's our degrees of freedom. So this degrees of freedom will help us to do what? To find the critical value. Will help us to find the critical value. Okay. Oh, do you all understand how to calculate degrees of freedom?
Yes.
Okay, great. Okay, that's great. Now let's check how to calculate critical value of test statistic. How to calculate. Okay. Okay. Where is it? I want one question. No. Let us look at option before we. Okay, let us now look at option 1. With this question, they say a study on the mode of transport that workers use to commute to work and the associated distance covered by each of the mode of transport is summarized in the following table. Then they say select incorrect statement. Then option 1. Option 1, they say HO. Remember, HO is what? We are dealing with independent variables. Meaning that there's no relationship between two variables. This one is correct. Option 2, H1. H1, alternative hypothesis. That one you're dealing with dependent. They say mode of transport and distance traveled are dependent, meaning that there's a relationship between the um the mode of transport and the distance traveled. This one correct. Let's now look at this one based on step 3, critical value. How do you find this one here? Remember, you will always be given what we call the significance level, this one, 0.05. You will always be given this one. So here we are going to use table 4. We check 2, which is DF, degrees of freedom, under 0.05. Let's check our table here. Check our table. You see, here it is, table 4. Table 4, critical value of x squared. Chapter 10, for chapter 10, you're going to use this table when calculating when calculating critical value. You see, critical value. We check what? We check 2 is 2 under 0.05. Where 0.05? This one here. Then here we go. Let's do it. We go, then go, we go. Then here it is. 5.991. That's our critical value. 5.991. Then we check here, chapter 10, 5, you see, 5.991. That's our critical value. So option 3, correct. You see, let me show another question. Let me show you how to calculate. Let us look at this one here. So when looking at question 10, they say, many companies use well-known celebrities and spokesperson in their TV advertisements. A study was conducted to determine whether brand awareness of female TV viewers and the gender of the spokesperson are independent. Okay, a sample of 300 female N is equal to 300 TV viewers was asked to determine a product advertised by a celebrity spokesperson. Now, the gender of the spokesperson and whether or not the viewer could identify the product was recorded. The number in each category are given below. You see now, they say at a 1% level of significance, the critical value, you see the word critical value of the test statistic, they are talking about table 4, critical value. So here, before we calculate the critical value, we start by calculating degrees of freedom here. Is equal to, now we find our row total, number of rows, then we find the number of columns. So here we count the number of rows. Identified product is number 1, could not identify number 2. So number of rows is equal to 2. Then now we find the number of columns. We have column 1, male celebrity, column 2, female celebrity. So number of columns is 2. Then we substitute. Then we say 2 minus 1, close bracket. Then we say 2 again minus 1, then close bracket. This 1, 2 minus 1, 1. 2 minus 1, 1. Then we say 1, then close bracket, then open bracket, 1. Here. Then 1 multiplied by 1, it's 1. here. Yes. Then after, we remember now we know our, oh, sorry about that. Now we know our degrees of freedom here.
Because of freedom.
We can now find the level of significance. Oh, we have degrees of freedom. We're going to use 0.01. Now we check on our table here. Where is it? We check here. We have 1. We check 1 here. It is. We check under 0.01. Here it is 0.01. You see. Then we go, you go. Here it is. Now that's our critical value, 6.635. 6.635, which is option 6.635. It is option 4. That's how you calculate critical value of the test statistic. Very simple, interesting. Any question?
No.
Okay, now let's now move to step 4. Is it? Let's now move to step 4. Okay, we are done with step 3. You see, step 3 we are done. Step 2 we are done. Step 1 we are done. Step 2 done. Then step 1 done. Okay, now here we are on step 4. Step 4, you compare the test statistic. In this chapter, you don't compare. In this chapter, we don't calculate probability. Please note this. We don't calculate the probability. We are dealing with test statistic and critical value. That's why I was saying that with this chapter, please make sure that you get full marks with this one. This one, we don't have probability. We compare test statistic to the critical value here, either to reject or not to reject the null hypothesis. Please be careful of this. If the test statistic x squared stat is greater than what? Is greater than the critical value here. We do what? We reject. We do what? We reject. We reject. We reject what? HO. We reject HO. If what? If this one here is greater than this one, we reject HO. But if now x squared stat, if x squared stat is less than what? Is less than critical value here, critical value of x squared, then we do what? We do not reject. We do not reject. We do not what? We don't reject. If it's less than, then we don't reject. Here we DF. We don't reject. Do not reject HO. Do not reject HO. If you master this, I'm telling you, never go wrong. We do not reject HO here. HO. Now let's look at one question. Remember, if x squared stat is greater than critical value, we reject HO. For e.g., if here now we have maybe, let me do this. Okay, if now for example here x squared stat we have maybe 20, then critical value then we have 14. So you see 20 is greater than 14. Therefore we do what? We reject the null hypothesis. For e.g., let's say here we have maybe 13 as our x squared stat, and then here we have maybe 19. You see now this one is the largest, so we'll just say x squared stat is less than this because this one is the largest here. Let's look at one question. Okay, chapter 10. One question here. Okay, let us now look at question 22. Question 22, when looking at this one, it is for one criterion used to evaluate employees in the assembly section of a large factory is the number of defective pieces per 1,000 parts produced. The quality control department wants to find whether there's a relationship between the years of experience and effect rate. Since the job is repetitious, after the initial training period, any improvement due to a learning effect might be offset by a loss of motivation. A defect rate is calculated for each worker in a yearly evaluation. Now, the results for 100 workers are given below. Okay, referring to the table, find the rejection region. With this one, please, with this one, there's no need for you to calculate the test statistic because that one is long. I'm going to give you the best method you can use. Here, we are given the level of significance 0.05. Remember, for you to calculate the critical value, you do what? You use degrees of freedom first. Now we find the row total here. Row total here, we have row to row, the number of rows. We have what? High, average, low, which is what? 3. Then column total, we have what? Column total, we have column for less than 1 year, column for 1 to 4 year, column for 5 to 5, column for 5 to 9 years, which is 3. Then we substitute 3 minus 1 here, close bracket. Then we have again 3 minus 1, which is what? Which is 2 multiplied by 2. 3 minus 1 is 2. 3 minus 1, 2, which is 4. Therefore, we know that we are going to use table 4. We check 4 under 0.05 by using this table here. We check what? 0.058 is. Let me do this. Okay, let me do this blue. Yeah. Okay, here we check 0.058 is. Then under what? We check 4. Let's go. Here, which we can use it. It's 9.488. 9.488. That's our critical value. Therefore, okay, where is it? Therefore, here you see, here it is 9.488. That's our answer. You see, that's how you find, that's how you compare. Then you are done. Any question before we move to the last step, step 5? Any question? Okay, let's
No,
look at
not yet.
last step here. Step 4 done. Then step 5. Step 5, you conclude. If the null hypothesis is rejected, then the two variables are dependent. It means that if now you say, I reject my null hypothesis, it means that the two variables are dependent. It means that there's a relationship between two variables. Now, if the null hypothesis is not rejected, it means that we say what? The two variables are independent. It means that there's no relationship between two variables. It's like this. If now x squared state is greater than critical value, then I say I reject my null hypothesis. Then it means that the two variables are dependent. And when the two variables are dependent, then we do what? We have the relationship between the two variables. Then this one here, if the null hypothesis is not rejected, then we say the variables are independent. It means that now, if you say, okay, if you conclude now, I say, I don't reject the null hypothesis. It means that there's what? It means that the relationship between the two variables are independent. And when the relationship between the two variables are independent, there's no relationship between two variables. Then we are done with chapter 10. Any question? Done with chapter 10. Any question?
No
Okay.
question.
Okay, thank you guys for attending. Tomorrow I will let you know during the day because I will be busy with something. That once I'm done, then we'll do chapter 11, last part. Then meaning that on tomorrow during the day, we must have a class during the day. Doing business, we must do chapter 11. Then we know that evening, then we do revision. Then we do a revision. Tomorrow is Wednesday. Wednesday, we must finish all the chapters. Then Thursday, the whole day, we must do revision. The whole day, revision the whole day. Starting with 2022 past exam paper. Yeah. I didn't make that one.
Okay.
Yeah, we are done with chapter 10. I'll send you chapter 10 questions on the group. Thank you guys for attending. See you guys tomorrow.
Okay, thank you.
Pleasure.